Most of you have had my forensics class. The one thing we don't ever actually do is physically image anything anymore because it's all in the virtual machine, and we'll get into more about that. So she asked me to do this presentation, and that's the main reason why I volunteered, is because I needed something better than what I had. So we actually made this. And we did not wait to the last minute. We actually waited until 5 o'clock. So we actually spent some time on this. Okay, let's make sure this works here. All right. Now, I'm going to cover a subset of images. There's no way I'm going to talk about every piece of software out there and every image type. But I am going to touch on some of the more popular ones, what we do with them, what they're used for, how they work, that kind of stuff. Okay? The main image types are physical, logical, and targeted. Okay? Those are the three. Okay? If you have questions along the way, just yell at me. I might ignore you, but it's okay. All right, physical. Let's talk about physical versus logical. Physical is what most of us do. Okay? Roy was nice enough today to make me a graphic. What we have here is we have one drive, which is what? 150 gig. It's funny, in my office, what do we got? 10 hard drives laying around down there now? They're like everywhere. So we made, Roy made an image. It basically took a physical disk and made a whole bunch of partitions on it, as you can tell. So this is all one drive. If I was to image the entire drive all as one, that would be a physical image. The entire drive. Okay. Logical, on the other hand, I could go and image the V drive or the W drive. Did you not get to Z? I thought you had all the way to Z.
No, I never got all the way to Z. You told me the graphics needed to stop.
Oh, that's right, because they were getting too small.
Right.
That's right.
So I did.
So, again, the physical, we'd actually be getting all the drives, including the free space at the end. Kind of funny, we got all these drive letters and still got nearly the entire drive is free.
I thought we were going to image K, so
Yes.
I put a bunch of funny pictures on
And then, again, if it was logical, we would actually be picking a drive letter. Okay, we'll see a little bit more about that. Okay. Physical is also known as bit stream, which is a bit-by-bit copy, or sector by sector. It's the entire drive. If there's a bad sector, you get a copy of the bad sector. Okay? So a set of files that can be used to create an exact image. Okay?
Come on, Jason.
Yeah. Hey, Jason. So with a physical or bitstream image, you should be able to reproduce it, create an exact image of it. So in my opinion, they're the most popular. At least that's what I use the most. Okay. Allows for examination without contaminating the original, and we'll talk more about that at the end. But hopefully no one works off originals in the real world, at least. Around here we have, but that's another story. It's a classroom environment, which is a little different. Okay. I have another lecture I give about hashing, but it's very important. If you're going to talk about imaging, you need to know what hashing is, because hashing is how you prove that it's actually the real thing. It's the exact image. Okay. So what hashing is take random data, text or binary, and generate a fixed size hash value. And I said it can be used to verify it. And one way you could think of it, I could take a windshield and smash it into 1,000,000 pieces, but I couldn't go back. There's no way I'm going to go from the smashed pieces back to the windshield again. Okay, it wouldn't happen. So I can always go from one way to the other, but I can never go back. Okay, and we're going to cover a whole bunch. And I have some demos we're going to see too, so I'm just going to do those at the end. Okay. All right, some examples. Here's an MD5, and here's a SHA-1 hash. Okay. There shouldn't be duplicates, but we're going to see here in a second there are, and that's an issue with them. Okay. What do you guys use mainly as for hash? Probably MD5 still.
MD5.
Yeah. Most people still do, even though it's been broken, basically. So yeah, MD5 is pretty much it. Okay. Created by, oh, that's a typo. Ron Rivest, not Rom. Ron Rivest in 1991 to replace MD4. Okay. In 96, they found a collision. And like he said here, the presented attack does not yet prove that there's an issue, but it proves that in the future there will be. There can be an issue, is what he's saying. Okay. 2005, man, That's researchers. As you can tell, I was very tired when I made this. Yes, reachers. Yeah, they're short for preachers. Okay, they're able to create multiple documents, and the bad part is that they're actually able to create multiple SSL certificates, different certificates that generated the same hash. So at that point, Revis said, you know what? It's done. It doesn't mean it can't be used. It's like DES. We all know DES has been broken. Hopefully you all know that. But it still encrypts your data.
Crap, I have to rewrite
So
that.
there's that whole timing this issue. I mean, using MD5 to validate, you download a file off the internet, which most places do. That's a perfect use for it. But if you're using something where it's very important, where it's critical that no collisions exist, then don't go with this anymore. Okay? So that's a little bit about MD5. And I'm going to show you examples of all these. I'm not going to show you a collision. No.
So NS5 is the same as MD5?
Did you say NS5?
It's approximately the same.
I didn't even catch that one.
Okay, if you're a deaf one, you'd be doing shots by now.
Sorry, I said I'm very tired.
Nobody else would find the errors either.
See, I got MD5 there,
Toads.
and MD4.
Control V.
Yes. So those of you watching this recording, it's MD5. Okay. Roy, you even looked at this. See, that's what I get. Yeah.
I saw it.
Yeah. If you don't know Roy,
He's in the microwave. Really?
if you don't know Roy literally gets paid zero.
It's true.
Literally.
No, nothing.
Zero.
No,
So I'm getting exactly what I'm paying for.
that's right.
Zero.
Take that.
All right. So let's continue on. Okay. SHA-1 is another very popular one. Some people prefer SHA-1. Developed by the NSA in 1995.
You trust those guys.
In 2005, flaws, again, basically they got flaws about the same time. All right, this is government agencies require SHA-2 after 2010, okay? And SHA-1 certs, once we hit 2017, are no longer going to work. Yes?
SHA-2 makes a lot of people scream.
Yes.
Especially managers that don't know what that means.
Yes.
Say, hey, your certs are not going to work. And they're like, oh my God, they're not?
Right. Yeah, search 2017, you know, way back when we had Y2K, this is kind of the Y2K of hashes. Because no one wants to change.
Except way worse.
So, you know, 2017, just go live in your storm shelter. And,
Google's trying to kill it off quicker.
They are.
So
Microsoft has already said, what now?
So this will actually cause problems.
Right, but the good thing is they know about it and they're working on it now.
Which means we'll fix it in 2018.
Right. What they said is like Microsoft has said, hey, we're giving everybody this drop dead date to have it fixed by, which means they'll probably start on it around then. And, you know, so we'll see. Yeah, Google's trying to get rid of it sooner. I mean, it makes sense. You know something's going away, so you start now. It's like I knew about this presentation a month ago, so I started today. I mean, it makes sense. Hey, no typos on that slide. Yeah.
MS5,
Good
guys.
idea.
MS5.
All right, let's continue. All right. SHA-2 is a collection of algorithms. There's SHA-256, 284, 512. First came out in 2001. There is no significant attacks against it.
Yeah.
So it can still be used. Okay? And it says in NIST in 2013 's developed SHA-3, which is not a replacement. It's a totally different algorithm. And it said it's not a replacement. It's just an alternative to the other algorithms. So we do have other options here. It's not like we need to come up. And I had the guy's name. I forgot to put it in there. But, you know, we have alternatives already. So, it's, you know, why not start making the changes? Now, what some people are. Google is, like he said, is trying to push for the changes right now. Okay? All right. Now let's talk about some image types. Okay? The three main ones are RAW, EL1, and AFF. And there's a couple others we're going to mention. Okay? RAW images are used to store volumes and disks, like I say. Normally, they're called DD images. Some of you have heard of DD. Most of you have heard of DD.
I learned about that today.
Roy had not, as of today. He's like, what? I'm like, DD, you know
Bad
DD?
person.
Huh?
Bad person.
Yeah. So but, again, we get what we pay for.
That's right.
But, hey, as of today, he's actually going to start getting paid. Imagine that. He's going to be... Finally got the budget approved today. He's going to take care of the V. He spent the last 2 months fixing the vSphere
Here
system.
we go.
We haven't paid him.
No, there's money here. So
Okay. All right. So But we have DD, we have DNG, IMG, and RAW. And there's a couple others I'm going to mention as well.
Right.
All right.
This is happening.
Now, EL1 is EnCase. And when you say EnCase, I'm assuming some of you have at least heard of it.
Yeah.
Okay, you could probably recognize it if you read the title, that kind of stuff. Okay, it is one of the most popular image types because everybody supports it. Okay, has the images of the disk, of the volume, can image memory, it can do logical files. It's basically the whole package. Okay, I just went to the EnCase conference in Vegas. It was kind of funny because I had to go there to keep my certification up to date.
I'm not sure.
And Dr. Hendricks is like, oh, no, we do not do conferences in Vegas. I'm like, not a problem. I can go to Houston. I can take a week-long class. It's going to cost $5,000 plus hotel, or you go to Vegas for $800. She's like, I think we're going to Vegas. So she's going to Vegas. So
Vegas
but-
required.
it was an EnCase conference, and I've had FTK training, I've had EnCase training, and all that other stuff. And I don't know if you've ever been to the official training by the companies, but it's funny because you go to FTK, which is Access Data, and they're the best. They will tell you every 5 minutes, we're the best. Everybody else sucks, we're the best. You go to EnCase training, and you even ask them, so how do you compare to Access Data? Oh, we don't. It's up to you to decide. So it was kind of a very nice conference, and it's doesn't pertain to this, with a lot of different speakers there, and one of them that was kind of interesting was about mobile forensics, because I'm assuming you all got mobile phones, these kind of things.
May have seen.
Nokia.
Okay.
For the win.
Well, iPhone, for instance, ever since the 4S, the phone's actually been encrypted based on a hardware key built into the device. So if you get a copy of my data without the device, you're not getting nothing. Okay. Same with 5 and obviously the 6 and so on and so forth. So it's pretty secure. But there's a major flaw. Does anyone know what the flaw is with it? Well, it seems that rental cars, whenever you sync your phone with a rental car, it transfers the entire image of your phone, decrypted, and stores it on the rental car. It does not remove it. So what's happening is hackers are going renting a rental car, pulling the drive out, extracting all the data, putting the drive back in, returning the rental car. Rent the next car, pulling the drive out. Because, I sync my phone up with my car, but that's my car.
So we need to steal your car.
Brilliant.
So, but the reason they do that is because the only way the car can play it is if it's decrypted, because it doesn't have the hardware key. So I know why they're doing it. It's kind of like the whole copy machine fiasco a few years ago. Remember when the police departments were making copies and was being stored on there, was never deleted? We actually had the issue with our copy machine. Now it's been replaced. So that's but EnCase, kind of a cool tool, and we are using it more in the forensics class now. But so that's what that image file supports. Okay, AFF, Advanced Forensics Format. It's kind of like an open standard. Okay, disk and volume information, metadata, that kind of stuff. Everybody know what metadata is. Most of you are in this area, so you shouldn't have an issue there. But, so those are the more popular ones. Then other formats. Okay, we have VMDK, which is virtual disk. The whole vSphere virtual environment is getting very popular nowadays. Hence, we might pay Roy to help take care of ours. Okay, ISO. We've all seen ISO before. Okay, what's ISO stand for?
ISO.
Nothing. It's actually named after the ISO 9660 standard. But it's pretty much an optical drive. It doesn't have to be anymore. It could be an archive, and now pretty much everything opens ISOs anyway. Windows 8 and all that does automatically, doesn't it? Like I thought it did. Okay. So VKI Virtual Box, and we also have window image file format. So these are just some of the other formats out there. So, and I think it's time to do. Okay, no, I need to talk about write blocking first. Yeah. Okay. Actually, this is a slide I forgot. I had to go back and add it. Okay. Write blocking is a big issue, and I actually have a write blocker right here. Okay. What this is I put it. What? Oh, that's fine. Yeah. But we put a flash drive in it here, and it connects to the machine. Basically, I can't write to the drive. Okay. I could not save to it. Okay. So what they do for us is it allows for acquisition of information from drives, devices, without accidentally screwing them up. We're going to get to the last bullet about that. Okay. They can block everything, which is what this one does. Literally allows no writing to it. Or you can block certain things. You can block, yes.
Is that a Tableau?
Yes, it is. Yeah. This is an older one. We have a newer Fred downstairs that has the newer Tableau built in, but yeah, this, it works. It's still good, but yeah, you kind of need one to prevent that whole accidental thing. Okay. So again, it can block anything, everything, or just certain things. But I don't know how I would feel about the blocking certain things. I don't know, that'd be tough. Okay. So it says native uses the same interface on both sides, whereas tailgate like this one is, it's a USB on one side, it's a FireWire on the other side, and with a micro USB on the other side. So different kinds. And those of you who've had my forensics class know the whole BL, AL thing. Anyone remember that? Before Linda, after Linda? Some of you have heard of that. We had this back before we owned a write blocker. Okay. We're a school. We don't have a lot of money. So I still wanted the students to image it. So it was actually in this room right here. I brought an image in here. And I was having the students each image the disk, the flash drive. So one by one, they were bringing up FTK Imager, which we're going to do in a second. And they each imaged it. No big deal. So whatever you do, do not write to it. Well, I give it to Linda. Linda was a special case. Okay, we'll call her that. So Linda takes this, it's her turn, so she grabs it. She takes her classwork and saves it to it. Like, what are you doing? I'm saving my work so I can make a copy of it. I'm like, no. You literally just wrote to my disk. And I tried everything I could. See, I had the MD5 of it, but I did not have an image of it. So I couldn't rewrite it. I even tried deleting everything, formatting it, putting it back on in the same order. No matter what I did, the hash value was different. See, the deal with the hash value is one little bit changes and the whole entire hash value changes. So for that project, we had the BL, the before Linda image, and the AL, after Linda image. So depending on when you got your image, that's the hash.
Right on here if you're a BL or
exactly.
Great appropriately.
Yeah. And you just don't think about it because, we all should know you don't write to the evidence, but she did. So,
Did you take 15 points off her grade today?
I don't even know. Yes.
So are software write blockers court admissible?
Yes, they are. If I remember, yes, they are.
But it's a harder case.
Yes, it is. It really depends on the entire device at that point. And it was kind of funny you mentioned software. We have a Linksys router down in my office. Little Linksys router, wireless, WRTG, whatever the heck. It's got a firewall in it. Comes with a firewall. Is that hardware or software?
Probably a software.
Okay, but what if I got a Cisco PIX firewall, hardware or software?
Which type of PIX?
The point is, what is hardware? Because all hardware runs software. So is it hardware, is it software? The firewall is still software inside the hardware. So it's kind of a fine line there. But normally if it's a separate device, like a PIX or something like that, it's considered hardware, or SonicWall or something. And software would be the Windows firewall kind of stuff. So if you got your Linksys router, that would normally be considered a hardware, but since it is really a multi-function device, you could say software. So I don't know, ever since this is 2 weeks ago now, it kind of blurred that line, because we always say, oh yeah, hardware's software, when it's not quite that easy, because things get blurred. And like you said, software write blockers are good. Ncase actually has one built in. I forget there's a name for it. It works. It's been proven. But again, if I went to court, it'd be a lot easier to prove that sucker right there. That hardware-based one. So there are a lot of other kinds as well. We have what's the one we got in the T? You asked me earlier what it was, and I told you.
The Talon.
Yeah, we got a Talon in there. We got Celebrite. There's lots of different stuff you can use the image devices with. Okay. All right. Now let's go do some demos. Let me get out of here. I brought obviously my write blocker. I wanted to show you a couple demos how this stuff works, okay? All right, installed on this machine, I have Access Data FTK Imager. In their words, it's the best. No, it's just easy to use. Okay, it's just very simple to use. This is FTK Imager 3.0. You can actually download it free from Access Data from their website. No license key required, although you're not supposed to download it unless you own a license. It's one of those deals, you need the license to run FTK, but you don't need it for the imager, but you should. So it's kind of weird like that.
So in order to get your marijuana tax stamp, you must present
Yes.
some marijuana to me and let me arrest you before I can
There
give
you
you
go.
the stamp.
There you go. All right. And another thing that's cool about this software, you know how you can actually run this off of a USB drive? It used to be off a floppy drive. I don't know. Does anyone actually even have a floppy drive anymore?
I still have one at the
I think it
house.
stubbed my toe.
It's nailed to
Okay,
the wall.
so, but you can run it off a USB drive. You can run it, you do not have to install it. You can literally just run it off of a folder. So I could walk into your office, stick in a USB drive, or download a file and just run it. So, kind of handy. And what this can do is it will allow you to image protected files, like your Windows registry. I don't know if you realize it's actually in use while the machine's running. You can't copy it. This will. You could actually copy the live running Windows registry while the machine's running. So it's,
Does that include the stamp file as well?
yes it does. Yes it does. Yeah. So, all right. So what I'm gonna, we're gonna add. Actually, we're just gonna create a disk image here. I'm gonna talk about some of the different options. We talked about physical drive. That would be the entire drive. Okay. And I have, actually, which drive do I have in there? I'm going to bring up computer management to see exactly which disk I have in here. I brought a couple teeny tiny little flash drives. Is this the big one or the little one? Let's see. This is the small one. Let me swap this out for the other one. Hopefully it detects it. I got a 64 megabyte flash drive.
Wow.
Yeah.
How old is that?
About 3 years.
Got into the trade show.
Yeah, actually, it's funny. I got this from Guidance Software. I got this from, Encase people when I was down in training in Houston. Because we even asked, why is it so small? I says, that's all we need. Okay, but you probably paid more to get a smaller device than you did to buy a bigger one. But it's 64 meg.
Yeah, you could have bought a terabyte, but no,
It's
64
called an
megs.
anti-theft device. Nobody wants it.
Exactly, that's it. Who would want this thing?
Put all your really important stuff on that. Yeah.
Okay, let's hope this next one loads.
Arguing on some
Come on.
Screw that. We're gonna waste the time playing this thing?
That's true.
Okay, let me stop. Okay, now we're going
Put one
to.
next to it with one gauge crudely scribbled on it, Sharpie.
All right, let's see if we can get this. I've had an issue with this one coming up, but it's a good one if I can get it to work here. There it goes. All right, so this one is an 8 gig drive, again, a very old drive. You'll see the left side is actually a 36 megabyte partition for my E drive, and the rest, basically 7.4 gigs, is free. So if I do a physical image of this, I'm going to get the entire disk, the entire 7.46 gigs. Okay. In case you're wondering why I format them like this, like in forensics, I have the students recover data manually, and I don't want to give them a terabyte drive or something huge. So what I do is I try to make it small. So
She got a terabyte.
So what I do is I go in there and I figure out how much space I'm going to need for the project, and I repartition it to be a teeny bit bigger because I got to store that image somewhere and give it to the students, so it's a lot easier. So you'll see here, if I do a physical, I'll get the entire thing, and if I get just logical, I'll get E. So, well, is it E or is it L? Whatever. It's E. Okay. So I'm going to go back in here. The wrong button. That button. I'm going to create a disk image. So we have physical, we've mentioned that. Logical, again, I could get just E. I could actually image an image file, like a virtual hard drive. Okay, could do contents of a folder. Maybe I want to image just my class documents or something like that. So I could do that. Could also do CD or DVD. I'm just going to make one. I'm going to do a physical disk. All right. when you select this, it's not telling me a drive letter. Does anyone know why it's not telling me any drive letters?
It's everything, right?
Because it's the entire disk. Remember, the disk could have multiple drives on it. So, I have a choice of a 500 gig or an 8 gig. So here's where you say, okay, this is a Seagate, or not a Seagate, it's a Patriot 8 gig, so that's the one I want. I'm going to get the entire thing, the 36 megabyte partition, and the rest, the 7.4. Okay. Now, when I bring it in here, so again, I'm getting physical disk 1, I get an option to add a destination. Okay. Here's when I can select my DD, my SMARM EO1. So we're just going to go with, we'll just go DD, it'll be quicker. Now, you do need to specify some case information, so I'm number 1, obviously. And we're going to store this. We'll just stick it on the desktop. That's fine. We've got to give it a name. This will be demo 1. Now, inside here, you can specify how big. If it's larger than a certain size, you can have it break it apart. Especially nowadays, 3, 4 terabyte drives. Maybe I want to transport them on CD or on DVD, so I need to break them up to 640 meg or 4.7 gig, or because that would suck.
This is my spindle that represents.
All right.
Don't worry, this is my case.
Now you'll notice the compression right here. The compression's grayed out. You want to know why it's grayed out? Why?
Raw.
There it is, raw didn't support compression. EO1 would have supported it, okay? I can also encrypt it. This is access data encryption, but they all pretty much read each other's now anyway.
Now you said there were 4 different ways that you could have brought this over. So the RAW does not support
It doesn't support compression.
compression, but the, what did you say?
The EO1, the encase format, and the AFF
AFF
will.
format will support.
Right, what that means is you can take this 8 gig drive and shrink it down to virtually nothing.
What about the other 2?
Smart does. I think AFF does. I'm pretty sure it does. I didn't verify that. Sorry. Okay. But what you could do in here, you'll notice it's not doing anything yet. I added a destination, but I could actually add multiple. So I could save it in multiple locations at the same time. I could save one in RAW, one in EO1, so I could actually save multiple versions at the same time. This is an important button down here. It says verify images. So in other words, it images it, then it verified that it actually did it, and it matches that whole hash thing. We're going to turn that off just for the sake of getting this quicker. Okay. Could also calculate the statistics. So it's funny because I had a 3 terabyte drive at home crash. So Roy was imaging it for me. We looked yesterday, had like negative 5 million hours. So I'm like, this will be done way back even before the Earth was made. I mean, it was. So the whole pre-calculation thing is not the best. You could also tell it to create directory listings. Be careful with that. We had a student came to us who had a drive crash. It got corrupted. It didn't crash. So he lost his whole file structure. But did he lose the files? No, they were still there. So he recovered them all. But it was his entire Windows volume with all of his data from years and years and years. See, he had like over 5,000 files on there. So
Windows XP.
it was so much stuff. And he's like, what am I going to do? I says, you're going to open up every file, because there was no names because he lost his directory structure. So,
But his backups were up to date, right?
yeah. But the good thing is, at least they could tell they had the extensions. That's a JPEG or that's a doc, so you can at least make some.
Versus losing your data, though.
Yeah. Like I told Roy, my 3 terabyte drive crashed at home. Yes, I would like it back. Do I need it back? No.
You don't need all those movies.
No, I can always download them again. It's not a big deal. And I actually have a backup service at work that I pay for. Rose State doesn't pay for one. If I want to back up anything at Rose State, they will bring me a tape drive. Seriously?
Sweet.
No.
What's up?
Wait, really?
Hold on.
Would they bring you the tapes, though?
Probably not. So I use Carbonite at home and at
Rose
work.
State.
Whoa, man. You're
All right.
asking a little bit.
So I'm going to continue. I'm going to say start here. So again, this is the entire physical disk. We are talking an entire 8 gigs.
It's going to take years.
Actually, this is a very slow write blocker. So actually, it will take a while. The new one downstairs is much quicker. It'd be like, done.
So you brought the cheap stuff up for us.
Well, I didn't want to bring the whole Fred up here.
Gosh.
You could have just brought the good one.
I would have had to bring Fred, and
Oh, right.
Fred's big.
Yeah.
Fred's heavy.
Fred's big and heavy, and this Fred has no wheels. And then we'd have to bring up all the monitors.
There's a thread across the hall.
That one's dead. Wow, this is literally taking that long.
Yeah, it's actually
All right.
about the same.
So we're going to pretend this finished.
Oh, yeah,
It was
Wow,
great.
that was so quick.
So what I'm going to do now, darn it, it failed. I shouldn't have really written much over there. Okay, so it did write it. It's just obviously not complete. I want to go back and do another one. This time, I'm going to do a logical one. All right, I'm going to do a logical drive. And imagine that I'm going to see, now you'll see with logical, now I have drive letters. I could do CDE, I could do whatever. So with drive letter, it was E, wasn't it? I think it was E. Okay.
Just do the C.
Unless you're
No.
actually running that.
All right. So, and I can always verify by bringing up computer here. You see E is 34 megs. So I'm going to do E. Okay. And again, I'm going to add a destination. And we were wondering if Smart supported it. Actually, let's do EO1. That's a good idea. EO1 is actually the most popular.
Why?
It supports everything. It's the disk information, volume information, memory information, file information. It's like the whole package, you know.
You're using FTK to create an encase.
Yes, exactly. Isn't that nice?
I didn't know if
You know-
anybody else got that.
Because they're the best. They
Okay.
do that.
Right.
I can't verify this, but I was swearing that a couple versions ago they actually had their own format.
Yeah, they did.
I thought they did. I'm like, wasn't there an access data format? It's gone. So, okay, because I thought there was, but it's
Yeah,
like
ACC or
something like that. Because it's like, where did it go? Because there was an access data format. Okay.
So good.
Well, they're the very best, except in file format and
Yes.
encase.
Yes.
So.
And yeah, see, this one does support. It supports the amount of whatever you want there, the compression. I don't care about compressing it. And I'm going to say go. I need to get at least, okay, this one's going much quicker because it's much smaller.
It's actually gonna finish.
Yes, this one will actually finish. Okay. All right, now when it finishes, I have an option here for an image summary. Okay. Now, I know you can't see this, so I am going to maybe copy it all, put it in Notepad over here. But you still can't see, but I can change the font over here. All right, so you'll see it actually tells me the information, what I copied, and it tells me my hashes.
Does it automatically hash it for you?
Yes, it does.
Or was that an option you selected?
No, it automatically does it.
Okay, so what's the difference between this and that option that you had, you deselected the first time about?
Oh, the verify. Verify does it twice.
Okay.
It creates the image, then it starts all over from the beginning, it does it all again, and says, do they match?
Oh,
Okay. I mean, it's a good idea. If I'm working on some super important case, yeah, I want...
Doubles the time because it's literally.
Exactly, I have to do it twice. And as we know, this one's a super high-speed one.
Right.
So, all right. But it does store all this information, so which is kind of nice. Now, what I want to do here is, okay, we saw that that worked. And I'm going to get out of there. And so on my desktop, I have my EO1. There's demo2.eo1, then there's demo2.eo1. And, you know, y'all know how to show file extensions in Windows? You need to. Because this stupid, not that one. Show file, whoever created this stupid option. Okay, hide file extensions of known file types. That probably creates more viruses than anything. Because what happens is, see, this is actually EO1, demo.eo1.txt. Since it was a known file type, it hid the extension. But the problem is, if it's an executable, it hides the extension. So I could actually take a virus, call it Roy's document.jp or .doc.exe.
Very important.
It would hide the exe, and Roy would say, "Oh, Roy's document.doc. It's Word file." He'd click on it to open it, just got a virus. So you need.
Roy.
And then I continue clicking on it.
What you need to do, if you haven't done this at home, you need to. I will show this to everybody. Go into Explorer here, go under Folder and Search Options, and right here it says Hide extensions of known file types. Turn that darn thing off. It's stupid. Okay.
It's probably safe to say that even a friend request from Roy is probably full of viruses.
Yes, exactly. All right. So again, if I open this up, that's the image we just, the verification information, and there's the EO1 file. Now, I'm going to bring in that, now I'm going to add an evidence item. In this case, I'm going to add an image file, and I'm going to add the one we just made. It's on my desktop, it's called demo2.001, or EO1, that's right, we did EO01. Okay, and I'm going to finish it. Now you see it's an actual image of it. Okay, there's the root, there was the files on there. Now if I image this again, you know, I could write this out to an image, so it is an actual bit-by-bit image of this disk. And if you cruise down here, you should see
I'll be happy to know
some
that you
files somewhere on here. There's a little bit. Okay. Yeah, a little bit of data on here, just not all that much. All right. So we saw that. What I want to do now, I want to do it again. Because if I did it correctly and I do it again, what should the hash be?
The exact same.
Should be the same. Okay, so I'm going to create a new disk image. Do the same way. It was logical. And I'm going to go down here to E. I'm going to add an EO1 image. And I will be person 2 this time. Okay, I'm going to put it on my desktop. And this will be Demo 2, Part 2. Until it finishes. Again, I'm going to leave all the verification unchecked. Okay, I'm going to open up the old one. This is the first one we did. I'm going to do that just so we can see it. It's right there. Okay, this one is done. So I'm going to open up the second one. And obviously you can't see it.
We'll take your word for it
No.
this time.
Actually, you know what?
Be able to visualize.
It saved a text file. That's right. There's a second text file. So if I did it correctly, these two should match. 6FE, so on and so forth, 6F3. So they do match.
All good, yep.
Okay? All right. We're not done. So that one matched. Everybody agree that matched? It's still an exact image.
Have you ever heard of a tool called Hashtag?
No, I haven't.
You need to download that. You just right click, go to properties on a new file, and it gives you a file hashtag. And you can paste other hashtags and compare.
Oh, okay. Yes, I have heard of that. Yes. I'm going to exit or eject this drive. I'll show you why. Okay. All right. Now I'm going to put this in here. So I'm actually putting it in my machine so I can write to it now. Okay. Now I'm going to go up here.
What is this notepad?
I'm going to add a period. Just a period. Y'all see that? I added one period to the disk.
Gas.
So what we are creating now is called the AL image. This is the AL image. Okay, so I added one period to one file. I'm ejecting it. Come on, tell me eject. Okay, maybe. All right, so I'm going to put it back in my write blocker. Actually, you know what? I want to put it back over here to show you that you can still do it without a write blocker. It's just not as safe.
You just want it to write faster.
Exactly, and write faster this way. Hey, it's got a good point. It won't hold up in court. They'll be like, what kind of write blocker you use? I left it at work.
USB right blocker.
All right,
That's right.
so now I'm going to create another image. I'm going to do the same way. It was a logical drive. It was drive E. And this time we're going to do EO1 again, so everything's the same. This will be, I'm examiner number 3 now. Yeah, and it's going to be called Demo
We're down. Okay.
3 now. Oh, no, that's the directory. Shh, don't make me look stupid. Okay, Demo 3.
It's okay, it's on the videotape.
Yeah, damn it. All right, so I'm going to start. Wow, it went
A little fast.
just a little bit quicker. All right.
Microscopic.
I think what you can
So-
do with a USB 3.0.
We'll upgrade to that in the future.
All right. So, all right.
After 4.0 comes out.
No, we'll wait till 5 and then. we'll-
Okay. So up at the top is the second one I made. Remember the first and second one matched.
Install this tonight.
So the third one, the one at the bottom, is the one I just made. Remember, I changed one period in one file. And look at the hash now.
The same, yeah.
Totally exactly the same. The word computed hashes matches, but that's the only thing that matches. So, yeah. Y'all agree that making a small change to the file, even if I put the period in there and saved it, went back in and removed the period and saved it, it's different.
Did you show this to Linda?
Oh, yes. Yes. We had a very long discussion on this. Okay. Now, that's the demo I wanted you to see. I could have walked through 20 more times, but one thing I didn't mention is like, okay, I'm assuming some of you might have a real phone like I do. Or you all got the Android crap. No.
Whoa,
well,
whoa, shots fired.
Imaging mobile devices.
Yeah.
So imaging mobile devices is actually a little bit different. Okay. Hey, hush. Okay. I can use Ncase to image this, and Access Data actually has their own tool, which they're going to give me a demo of next week. When I image my phone, what type of image do you think it makes? A physical or a logical?
Useless iPhone.
Logical.
It's a logical. Because the device will only let the reader get certain data. And I've actually proved it. If I format, put a bunch of data on it, then reset my device, I can't get that data back. Now, I asked the question at the conference. I said, but can't we get a physical copy of it? And actually, we can. We can use Cellebrite. We can use a couple different tools and actually get a physical image of this disk or the device. But the problem is it's encrypted with a hardware key stored on the device, which I can't get. So yes, I can get this image, but now it's encrypted and you can't do a darn thing with it.
Is that only for the 6?
No, it's 4S and beyond. Okay. Now, what was the other thing there?
What about getting a physical image of an Android?
I don't know the newer Android, but the older one I got, it's not encrypted. I don't know the newer Android. I haven't imaged one lately. I need to do that. Probably need to do it for this semester, but I haven't done the newer Android. But like Cellebrite, some of you have heard of Cellebrite. It's used a whole bunch in law enforcement. It's used a lot in mobile phone stores as well. That's used mainly, like if you bring your phone to AT&T, buy a new phone, they will copy your stuff from one phone to the other. So what that does, we actually own a copy. It costs us like $9,000. And if I want to image this device, I don't get a single file. I basically get a copy of everything that was on here. Every SMS message is stored in a text file. Every image is stored in a JPEG file. So I end up with 8,000 images. The only reason I haven't used Cellebrite to make an image for my class is the reason I use Ncase, because I get a logical. So that's kind of, that was an issue for me. I was like, there's got to be a way to get a physical image of this device, which I can, but I can't do anything with it because it's encrypted, and no one has figured out a way other than rental car companies. But again, that's the device allowing it to store it. They
Well,
just
then go
should be
sync
deleting
your
it.
phone with a rental car,
Yes.
take the drive out, make an image of it,
That's why-
and then,
That's why it's the phone choice for pedophiles.
Oh, that's
Didn't
true.
you hear the FBI say that?
Yeah. And basically say, without the key, you ain't getting anything off this device anymore. Because it actually encrypts everything. Like, I got the Touch ID on here. Encrypts everything with the hardware key, plus it integrates either my passcode or whatever on here. And you know that the cool little Androids, you can draw the symbol to unlock your stupid phone? That's stored in a text file? It's literally like it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's like 1, 6, 2, 8. It's just how you drew the line. So you just take the text files. Oh, so this one, this, so you can unlock the device. So it's,
If I didn't know better, I think you're biased or something.
yeah, we really need. You have a Android crappy phone over there. So I think what we need to do is image yours and see if it's stored encrypted. I don't know. That's a good question. I need to try that.
We can do mine.
December.
I volunteer.
I volunteer.
We're not doing it tonight.
Ah,
No.
right.
You're no fun.
All right. So you learned a little bit about imaging.
There was nothing obvious.
Hopefully a little bit answered some of your questions. Is there any other questions?
I'm ready. Let's
Now, if
go.
I don't know the answer, I'm going to refer to
Google.
Kelly. All right. So, all right. Yes, go ahead, Chris.
So how do you get live image acquisitions for machines you don't have a password
That's actually a very good question.
Theft
Um,
is an option.
Now, certain things, like I know access data, for instance, you can actually do a live memory capture of it. You can actually get a live, but you need to get the agent onto the machine. So depending on what shares are open and what access you have remotely, you can possibly install the agent. Like what I do in my class, I have access to administrative share. So remotely, I push the agent to it. So the device has a password on it, you might still be able to get it. Okay. Yes?
Really cool tool, NSA Playset, that company, they came out with something called Slot Screamer.
Okay.
And if you have physical access to the box, you can drop it in a PCI Express slot, and it uses a tool called Inception, which used to exploit a
Saw the movie.
FireWire DMA. Yes. There's actually a FireWire DMA exploit that allows you access to lower 4 gigs of memory over FireWire. Well, they rewrote the tool for PCI Express, and what doesn't have PCI Express? So they built a bunch of cables, so you can adapt it to even like little Intel NUCs, the little tiny ITX systems. And you plug it in, you get access to lower 4 gigs of memory, and in almost every OS you're going to see, you can actually overwrite the password in memory with whatever you want.
Oh, nice.
Completely non-persistent attack, log in even if they have whole drive encryption.
Oh, nice.
Pretty fun stuff.
But does that work if the machine's powered on, or do you have to power
Machine
it
needs
off?
to be powered on.
But do you have to power it off to put the card in?
Yeah.
Oh, well, you know, I think they...
That'd be
I can't
tough.
answer that. I think I fell asleep halfway through the talk as Vegas.
I don't understand. I've been to a few of those. You know, I was telling you how wonderful the conference was, but it was funny. You know, all the talks were an hour and a half long, hour and 20 minutes, something like that. And they sit there with a scanner, and they literally scan you in to each talk, because they're giving you credit for being there. You know, for my certification, I had to attend 10 hours of talk. So they scan us all in. You know, the little badge had a QR code on it. Then we're in there for an hour and a half talk, and about 15 minutes later, the guy says, all right, I'm done. We're like, what? Oh, yeah, that's all I got. See you later. So we all start leaving, and the people are like, where y'all going? We're like, he's done. Like, no, you got another hour and 15 minutes. So his talk sucked.
Nope.
I don't remember what it was, but it was terrible. But overall, it was good.
But is your favorite speaker?
Yeah. One thing that, actually, I was talking to Roy yesterday about this. You know, I do a live, active memory capture in forensics. But when a machine's actually running, if you have your browser window up, it'll actually store your password in memory, decrypted. So that's the one thing I told you, we need to redo that lab. See, when I originally made that lab, we made it with as small amount of memory and space as possible to make the image smaller. But the password paged out to the page file, which I didn't copy, so kind of sucked. But
We'll just take the page file off.
actually, we actually could image the page file, so we'll have to see it. But yeah, the way it stores stuff is all different. So depends on what your access is. If you have admin access, even remotely, you can force stuff on there nowadays. And a lot of things will auto run even when they're locked. So if you can auto run, then you can install all kinds of stuff.
So when you see, it's when somebody's been killed and they want to get into their computer, they have to.
Well, not them, but somebody else.
Right.
Right.
Yeah, if they're dead, they probably don't care.
Well, like the police have to get into their.
Right.
Okay. Or a family member.
Right.
Then they would have to use like what he was.
Right.
The
Right.
PCI.
Well, kind of along the same lines, a lot of you know Dr. Schnoy from University of Tulsa, and some of you heard the story already, but some of you haven't, that's why I'm repeating it. But they had a BlackBerry, the Secret Service had a BlackBerry that they needed to get into. And it's one of those, if you put the password in wrong so many times, it wipes the device. Well, the Secret Service was basically up to that number. Screwed up again, you lose all the data on the device. So Dr. Schnoy's students took another BlackBerry. They always work on a different device to perfect how to do it, then they just do it again on the real device. But they took a BlackBerry, took a laser, cut off the top of the processor where the ROM is stored on the chip, and actually read the hex bits of the password, broke it in a password hacker, put the phone back together, logged into the phone, and got all their data off of it.
I thought that was a tense pin to actually.
But yeah, it's just, the thing is, like up at Dr. Schnoy's program, they don't do normal stuff. They're not going to find oh, I can download NSA whatever. Well, there is no such thing. So they have to make their own stuff. He has a PhD student up there who just did his dissertation. There was something, I can't remember, some imaging thing that took like 30 days. Took forever. Whatever the heck they were imaging took forever to image. And he got it down to 30 minutes. So, and he was like, wow, no one in the world has been able to do this, whatever it is. So they're doing a lot of cool stuff in it. So even, we talk about a lot of software, but, there's a lot of you got to figure out, and I'm real big on those of you who had me in classes, figure it out. This week we're doing the online password breaking where I give them Kali without the password. I'll be darned. What's the password? Figure it out. It was funny because it was actually last week they did this one. This guy messaged me, I can't get in. What's the password? I tried everything. It says figure it out. So he goes on the discussion board. I've tried everything. I can't get in. Will someone please help me? I'm like, someone gave it to him. I'm like, seriously? You type
figuring it out.
You type Google and say password for Kali. Boom, there it is. It's root and Tor.
It took more effort to go to the discussion board.
Exactly.
Yeah, but who's going to do a default password in this series?
Yeah,
but, it's...
especially in the cybersecurity class.
And...
I need to do something, guys.
And they're working on, this is the project where they have to break in with Telnet. Some of you remember that project. I tell them, use a valid username, can contain one or more or none of spaces and periods and mailboxes and smiley faces and Windows flags and all this weird ASCII art. Students say, how do I put a smiley face in my username? You don't. And it's like someone today, they actually sent me their username list. I don't know how they got it in there, but they had a Windows flag in there. So how did you get that into your username? I don't know what they did. And I'm like, no.
You do a AthiKids controller alt, I can't remember, but you type in a 4-digit code.
Yeah. Right. But it's like, but the whole point of that is you're supposed to look, what's a valid username? Other than an @ sign, which we know is an email address, who has a username with a flag in it? Yes, my username is KFlagooey. It's
guaranteed. Nobody's gonna have a rainbow table for that.
Exactly. That's true. But it won't work. For some reason, Telnet kept rejecting. I'm like, first of all, you got spaces in your name on some of them. You got flags on another. You got a smiley face on another. They're like, and they're like, but you said. I said, no. I said, use some, all, or none of these. I didn't say you had to use them.
You should have had him run Wireshark on it when he was sending those usernames.
And it's probably returning, what the hell? What the hell?
Are you sending a closed code?
All right, I'm going to stop the recording now. I think I covered enough of this. And we are going to say a quick prayer that it actually says.